Good evening, students. In this video, we will try to understand the concept of how exactly high blood volume leads to acidosis and how exactly low blood volume leads to alkalosis, a phenomena often called contraction alkalosis, right? We'll try. It's a simple and beautiful mechanism, right? And we'll try to understand it, right? So for understanding how exactly high blood volume leads to acidosis and low blood volume leads to alkalosis, we need to understand how exactly bicarbonate is actually reabsorbed in our body, right? So we'll draw a cell of PCT, proximal convoluted tubule, right? Right, PCT, and it has got two sides, one basolateral side and one luminal side, right? Basolateral side means what? Basolateral side means on this side we have got blood vessel, right? And luminal side means what? On this side we have got the filtrate which will ultimately become urine, right? On this side we have filtrate. Right, and on this side, basolateral side, we have got our main hero. What's the name of our hero? Is the sodium potassium ATPase pump, right? So what it will lead to? Less sodium inside, right? So who will use this sodium gradient thus created? The sodium hydrogen exchanger, right? Sodium will come inside and hydrogen is going out, right? So why sodium is going inside? Because we have got less sodium inside, which has created a gradient. So sodium is using that gradient to come inside and hydrogen is using that gradient to go outside, right? Now how this hydrogen is being created inside, right? We have got a chemical reaction, right? H2O plus CO2. This will give rise to H2CO3, right? And this will give rise to our H plus and HCO3 minus, right? This H plus goes out. In exchange, the sodium comes in, right? This HCO3 minus will go out and in exchange, we will get Cl minus coming in, right? It's called bicarbonate chloride antipode, right? Now, coming back to our question, how exactly the bicarbonate is reabsorbed over here, right? How exactly bicarbonate is reabsorbed? Now, bicarbonate is coming from here, right? This bicarbonate will combine with our H plus ion, right? So this H plus ion will go and combine with this bicarbonate, right? So what it will lead to? It will lead to H2CO3, right? This H2CO3 will then dissociate into H2O plus CO2, right? Okay, and this H2O will then go inside. CO2 will also diffuse and this H2O will go inside via aquaporin 1 channels. This is PCT. That's why we have got aquaporin 1 channel, right? CO2 is highly diffusible gas and H2O will go through aquaporin 1 channel. And this aquaporin 1 channel, once it enters inside the cell, on this basolateral side also, we have got aquaporin 1 only. And this is not dependent on ADH, right? In your collecting duct, we have got aquaporin 2 dependent on ADH. But this thing is not dependent on ADH. So this water will move towards the basolateral side, cross the basolateral side with aquaporin 1. And ultimately reach where? Our blood vessels. right? Now, if you see the whole thing carefully, right, this HCO3 minus is not getting reabsorbed directly. It's not getting reabsorbed directly, but indirectly if you see, this got converted into H2O H2O plus CO2, right? And ultimately the whole thing broke down to bicarbonate, right? So we can say this bicarbonate was reborn and went inside, right? So it's the same bicarbonate. It was not absorbed directly, but after dissociating into H2O plus CO2, right? And H2O plus CO2 got combined, right? And then again dissociated, we finally got our bicarbonate, which was reabsorbed, right? Now coming back to our question, right? How exactly high blood volume leads to acidosis and low blood volume leads to alkalosis? Now see this diagram once again and just wonder why exactly the high blood volume will lead to acidosis and low blood volume will lead to alkalosis, right? The reason behind this is that this bicarbonate, to get absorbed, has to first get converted into H2O plus CO2. So this step is important, right? And both these steps are catalyzed by which enzyme? Carbonic anhydrase. In short form, I will write CA. Even this step and this step. So this bicarbonate, to get reabsorbed, has to first get converted into water plus CO2, right? And once this water gets absorbed, it gets converted into bicarbonate, right? So understanding this will help us arrive at our answer. Now let's come to our blood vessel, right? Now suppose this blood vessel has got lot of blood, right? The blood volume has increased in this blood vessel. That means lot of water also, right? The blood volume has increased in this blood vessel. Now, if blood volume has increased in this blood vessel, right, will the water flow through this aquapore in one channel? No, right? Because it's already having lot of water, so this flow of water will be impeded, right? Right? And since this cell itself has got now a lot of water, right, even this flow of water will be impeded, right? If this flow of water is impeded, bicarbonate won't be reabsorbed. If bicarbonate is not reabsorbed, it will be excreted out, right? In high blood volume, this bicarbonate will be excreted out. And if this bicarbonate is excreted out, if you lose bicarbonate, what you get? Acidosis, right? Acidosis. So as simple as that, you get high blood volume over here. So the flow of blood through this aquaporine channel is impeded. This cell has got lot of water. So flow of water from this side is also impeded, right? If flow of water from lumen to the cell is impeded, right, the bicarbonate won't be reabsorbed. If bicarbonate is reabsorbed, that means the bicarbonate will be excreted out. If bicarbonate is excreted out, that means it will lead to acidosis. As simple as that. Now take the other scenario. In another scenario, the blood volume is less. Right? If blood volume is more, what it will lead to? Acidosis. Right? If blood volume is less, what it will lead to? If blood volume is less, that means it will try to reabsorb more water from this side. So more water will go through this aquaporine 1 channel. If more water goes through this aquaporine 1 channel, now this cell will also ask for more water from the tubule, right? If more water goes through this tubule, that means lot more bicarbonate will be generated inside the cell. More water means more water to combine with CO2, H2CO3, and all this bicarbonate will also be readily reabsorbed, right? This cycle, this overall cycle will become fast, right? So lot more water will be reabsorbed, this bicarbonate will be reabsorbed, H2O plus CO2 will dissociate and form lot more bicarbonate, and this will go inside the blood, right? And this will lead to what we call contraction alkalosis. Less blood volume leads to alkalosis, right? Contraction alkalosis. Less blood volume means contraction alkalosis. Okay, so let's sum it up, right? If we understand the basic mechanism of how exactly the bicarbonate is absorbed, right, then we can readily explain how exactly high blood volume will lead to acidosis. If the blood volume increases over here, right, you will get less water flowing through this aquaporin 1 channel, right? This means this cell has got lot more water. That means less water flowing through aquaporin 1 channel on this side, right? If the less water flows through the aquaporin channel on this side, this bicarbonate won't get reabsorbed. If this bicarbonate is not reabsorbed, it will be excreted out. Excretion of bicarbonate means acidosis, right? If you got less blood over here, that means more aquaporin channel flowing through these, more water flowing through these aquaporin channels. If more water flows, then this cell will ask of more water from the lumen. If more water comes from lumen, more bicarbonate will get reabsorbed and regenerated inside the cell. And this bicarbonate will flow inside your blood vessels, leading to alkalosis, often called contraction alkalosis, right? Which you may get in diuretic therapy and vomiting, right? So hopefully this video has helped you how high blood volume leads to acidosis and low blood volume leads to alkalosis. Wish you all the very best. Thank you.